GLM modelling wouldn't be complete without checking the residuals for conformance to what we expect to see for the error distribution we chose. Select Residual Plot from the navigation menu. On the left axis of the resulting scatter plot, you can display the raw residual, as in this case, the Pearson residual, by selecting this, or the deviance residual. On the bottom axis, we can plot the residuals against the linear predictor, or the sum of the betas, the expected value, which is a linear predictor run through the inverse of the link function, as we saw in the SAS scoring code, or the actual response values. Each dot on the scatter plot is a record in the data. However, it has been capped at 1,000 data points. These 1,000 data points were randomly selected by Preddle from the dataset. Notice we're looking here at the size workspace, which we fit in an earlier part of this tutorial. If the distribution of points seen here displays bizarre patterns, then you might want to think about changing the error distribution in the workspace settings. There is plenty of literature on the internet of what are expected error patterns and what are bizarre error patterns, but I'll briefly make some points. If you choose the normal error distribution, then the residuals should be a cloud of points with no pattern at all. If you see a pattern like fanning out like a funnel, like what this is, where it starts off at the narrow end of the funnel and then fans out wider and wider, then the normal error distribution will not be appropriate. Likely we didn't choose the normal error distribution for the size workspace. However, if you focus on or gamma distribution, which we did, then the raw residuals should fan out like a funnel. How convenient. Now the Pearson residuals, and even more so the deviance residuals, should strip out any prior shape like this that might be present in the raw residuals. So if we change this to the Pearson residuals, we should expect to see no shape at all in the cloud, which is what this is. It looks a lot more random. However, if the response was simply 0 or 1, such as it was for claim frequency, for example, then the residuals will just form two lines like this. Whenever the model probability is whatever the model probability is for a record, either the actual outcome will have been a success or failure, either 0 or 1, with nothing in between. There isn't much to interpret in the residual plot for success or failure models like this. So this particular chart is less relevant for frequency and binomial outcome models than it is for, say, size models.